Since our last call last week, a lot of people reached out to me, not only on LinkedIn, but on YouTube as well. And they reached out to me and asked, so what is actually the direction I should go? What are the paths I can take? And yeah, you were so kind to told us how to overcome some challenges that you came across when you took the challenge to come from India, going to the UK, finding a job in robotics. But yeah, a lot of people are unsure, and you mentioned a lot of these subtopics in robotics last week. So I'm having this session today with you because of the high demand of people that reached out to me. And yeah, you were so kind enough to say, okay, let's dive deeper into that. What are the areas I should go into? Where should I start learning things about robotics, especially people that are just getting into their bachelor's? And yeah, I would like to ask you, maybe you can help us and trying to find out what can be a good approach. Last time we were talking about finding a job, but here we're actually going a step earlier. How can we actually get into robotics? What are the fields and what are the ideas that you had? Because you said, I remember clearly that from a very early age, you had an idea which direction you would like to go. And maybe you can talk a little bit about this.
Yes, thank you. Thank you, first of all, for this opportunity. And I'm glad that people found what I said very helpful. And it's great to be here again.
Mm.
Going back to the, so let, so I want to approach this conversation in a way that it needs to make sense to everyone who is just starting out, who are in their first, second, or third year of engineering, or if they've already graduated. So this should make sense to everyone. And the way I thought of approaching this is by exposing a lot of information, a lot of jargons. So the way to consume this podcast would be to have a piece of paper and a pen, note down all the points so that you can go back and read more into it or research, or just drop me a direct message on LinkedIn and we can have a conversation. So that's just a disclaimer that I want to share before I begin.
Thanks.
And thank you. Before I start with what needs to be done, let us focus on the problem. So the end goal and the problem statement is to find a job or land a job or be a robotics engineer, be a roboticist. So now going back to it, understanding why a company would hire you, they require certain skills which is based on the job description. So what I now, for somebody who doesn't know what are the different aspects of robotics and how to begin your journey, how to research about it, my go-to advice to such students is to go on LinkedIn, look up for robotics engineering jobs, robotics engineer or robotic software developer or controls engineer for quadrupeds, for mobile robots, for navigation engineer, and read the job description. Try to understand what these jobs are looking for and try to take a note of the skills that are required for those job positions. If you don't know anything about robotics, and then you will start to get an idea of the field of robotics, because all these companies usually have a very brief introduction of what they do, and then you'll start to understand what you learn at university is a bit different than what industry expects you to do. What skill set you gain at university level or on academic level is a bit different than what is expected from you when you work in a production level environment. So when you know what problem you're trying to solve, then you can break down the solution. For me, it started pretty early. I was exposed to the entire field of electronics and circuit building, and I was exposed to the term robotics back in 2013. I was only 13 years old, watching television. I saw a person with a job with the title of robotics engineer. And that's when it struck me that, hey, this is also a career. It's a domain. People can call themselves robotics engineer. I want to do that. That's when I decided that I want to do it. Every step I took was towards that direction.
But what I want to understand is that because this is a very end goal driven path, right? So you said, okay, in the very end, the end goal is getting a job in robotics, and which is definitely something that people should keep in mind, right? It's the same when you're building a product and you're a founder. Is there something that interests you, or where you would be able to find people that think that this is a solution that fits to my problem, and I would be able to, and I would be willing to pay for that, right? To pay for that solution. But my question is, aren't you limiting yourself if you're using that approach entirely? Because there might be a high demand at this moment, and we spoke about this last time as well. So, but that doesn't mean like in 5 years the same need is still there. So, do you think this is not necessarily the entire path that someone should take, versus use this as an inspiration because you don't know how vast the field of robotic is? Here are actually things where a robotic role is applied to. So if you would like to go into robotics, have a look at LinkedIn because it can shows you where you can end up. Right. And when you can end up and you say, this is actually something I would like to work on because this catches my curiosity, my interests, then work your way back towards what should I learn to gain those skills to be finally able to work in that job.
So you're right. You're right. This can limit the potential of an individual, but I want to stress on the point that to know what skills you need to pursue or to get some exposure of what's required, you at least need to know. And I think job descriptions are a good place to start with, just to get an idea. And then once you have that reference, let's say the way I do it is I go online, look for a few job descriptions, and try to note down the skills and do it every month, once or twice a month, see what job descriptions say, and you note down the skills, take a note of it, and when you're free, when you have time, research about it, read more into it, learn more about it, try to see if that's for you. And when you are starting at a very early age, let's say your first year of undergraduate, you you at least have a vision that I want to do something in the field of robotics. Okay, I want to explore this field. So now what should I do at this point when everybody else around me is not focused as much as I am? I'm not able to get the right guidance because most of the times what happens is the first year of engineering is a mixed subject study. You study everything, starting from chemistry to physics to workshop practice to every single thing, environmental science. So you might not get the right guidance. In that case, you what you need to do is go online, see what robotics is. Robotics is a very umbrella term, it's a very vast term, and it cannot be narrowed down into one or two different domains. So later during this podcast, I'm going to share a lot of domains that you can explore, you can read more about. And the way I would do it, if I had to do it all over again, I would try to find good mentors and good people surrounded in front of me or surrounded by me so that I can have these discussions not just with myself, but with the people around me. Finding true mentors is extremely important because they can make or mar your entire path, your entire career. You only need the right guidance, the right push in the right direction, because everybody works hard, but the difference is who works hard in the right direction. And to know which direction is right for you, you have to start exploring at a very early stage. And the faster you explore, the faster you know what you don't want to do, the more time you can invest in what you actually want to do. So when you're starting out, try with, so Arduino is a platform, open source platform for developing small circuits. It's a microcontroller. You can connect it to sensors and actuators, program it using C, and use Arduino IDE for programming. And you can see your code in actually doing something in real life. And that will give you a lot of insights of what robotics is. It is all about giving certain inputs, processing the inputs, and providing certain outputs. The inputs can be code driven, or it can be sensor driven, or it can be any other thing that gives that input. So my approach is try to learn a microcontroller first, and then let us travel, like proceed our way to microprocessors, to different domains that can be implemented on those microprocessors and microcontrollers. What do you think about that?
Um, I think you have a lot of advantage if you really are being that kind of professional, because it takes a while to actually gain that kind of kind of maturity, right? So because that means you're being very serious, very early stage in your career. And you definitely have the advantage because, as you said, if you do this on a very regular basis, you are much more focused and you have the eighth wonder of the world, the wonder of compounding. So the compound interests, so kind of so to speak. So you're starting, and then you have months after months after months, year after year after year. So when you're finished university, you have the advantage of all the time up front that you put into that. So when you're coming out of university, you already have the skills that are required in the job descriptions. You already made the practical experiences, not only through the university projects, but in your free time, right? As you said, get together with different people, work on projects on your own. This is the way you gain experience. This is the way you gain knowledge. Your learning curve can be much higher, especially if you have a few people in your group that are older than you or more experienced than you, more skilled than you. So it does make sense to surround yourself with people that are better than you, even though it can intimidate you and it can make you feel stupid at times. I think this is definitely something that in our education systems, even though they're different, I think this is definitely something that is so underrated. So the idea of if you're starting early enough, and it doesn't have to be like a big mountain of knowledge or training that you're gaining, but over time it will compound and it will put you in a much better position. But tell me, I would like afterwards, I would like to share some, because people are asking me, share some resources that you have and maybe even books or courses that you can suggest. We have a lot of people that are looking for this kind of guidance. So where should I have a look at? What are the courses? What are the YouTube channels? What are the open source projects I can participate to gain that kind of knowledge? So afterwards, I'm not 100% sure how I will provide this, but I would like to. I think in YouTube, I will put it in the comments. I can pin it, and on Spotify, I think we'll be able to put it in a Q&A afterwards. I think this would be definitely valuable. But back to you.
Thank you, thank you. I do have a lot of resources to share. The book that I started learning my entire robotics journey was, it's called Theory of Machines, and it's by S.S. Ratan. It's an Indian author,
Hmm.
and it's, I think the PDF version is available for free on the internet. You just have to search for Theory of Machines by S.S. Ratan, and it's a good book. It's a very beginner friendly book to get yourself exposed to the field of robotics, kinematic linkages, forward kinematics, inverse kinematics, dynamics, what are Jacobians. All these things are very important, and the earlier you learn these things, the concepts you make them clearer, it will be better when you actually implement it in real life. And the thing that I studied during my third semester of undergraduate, which was my second year at undergraduate, I was applying that exact same knowledge when I was pursuing my master's degree at UCL. So that knowledge helped me even after 4 years when I was pursuing my master's. During every project, that skill is required. What are DH parameters? How to calculate it? What is the physical significance of those parameters? What are industrial robots? And how can DH parameters be applied to industrial manipulators? And what are the different robotic arms in for educational purposes? Like, I think it's by Elephant Robotics. It's called MyCobot. It's a very beginner friendly robotic arm for projects. They have a gazebo.
I know it, yeah.
Yeah, they have a gazebo model for it, URDF model for it. It can be simulated. UR5, universal robotic arms, universal robotics arms are also very beginner friendly. They have good packages to simulate and learn from. Nideo One is also a very good beginner friendly robotic arm that you can explore. There are multiple mobile wheel robots platforms. If you talk about a very famous one, it's Turtlebot. It's also very ROS friendly. I'll talk about ROS after some time. But Turtlebot is one of the robotic platforms. The Tortoise Bot, which is by an Indian startup called Rigbeetle Labs, is also a very good platform to study this. It's all open source. It's on GitHub. I would urge, if you are a first or a second year student, I would urge you to go to GitHub Look for repositories with resources, with projects. There are multiple repositories of repositories that have multiple stars, so it's easier for you to find. If you go to my profile, it's Akshat P, capital P. You can see my starred repositories, and out of 50, I think almost 40 are just robotics based repositories. You can go check, see what works for you, and take note of all those important repositories. There are a lot of resources online, you just have to look for it in the right place. A lot of YouTube channels like Articulated Robotics. James Bruton is a person who's a fabulous roboticist. He creates robots like sci-fi movies, and they look good. He explains everything. It's all available on his GitHub repository. It's all open source. He explains how he implements the controls, shows the experiments. If you want to learn about, I suggest Python and C++ should be learned by everyone, no matter from what background you are. Both of these languages hold utmost importance.
Have you heard? I think it was just yesterday or the day before yesterday that the CEO of NVIDIA just said that teachers and parents should stop telling their kids that they should start programming because in the very near future it will become obsolete because there will be AI will be actually taking care of that. And so there will be no programming language. I haven't read the entire article, but I think it was something like you don't need to learn a program language because in the future we will be able to talk to robots the way we talk to each other. So, what's your take on that?
I have a very hot take on that. I think, okay, that might be true and that might be the future. But right now, the need of the hour is to understand programming and understand how to make the machine understand human language. It's the need because even during the interviews, what I have observed is they want to understand how to debug the code, how to troubleshoot network problems, or if your code breaks, or the core programming concepts like what is dynamic memory allocation, what is memory allocation, or what is a compiler, how does the compiler work. If you are given a task to optimize the code, you cannot keep asking chat gpt to, "Oh, optimize this code." It's not going to work if you don't understand how those optimization work. If you don't understand what is time complexity, what is space complexity, you need to understand the concepts of programming to be a good robotics engineer. Anybody can be a robotics engineer by just prompt engineering good prompts to chat gpt or any other large language model, and say that, hey, I need a code to compute the forward kinematics for this robotic arm. It should travel from this point in space to this point. Give me a code. But okay, that's good for an academic project. You can learn from it. You can learn from how the code is written. But when you go to a production level environment, the company expects you to write crisp code, which is time efficient, which is energy efficient. Everything that you write is related to money. Every code that you write, it needs to be executed quickly because it's going to cost energy, and energy is going to cost money. So that's my take on it.
I think just yesterday or the day before yesterday, I read. I guess you follow him as well. So there's Audra Nash. He works at Intrinsic AI, and
Yeah.
he was the host at Sense I think Act, the robotic podcast for a few years, and now he has his own podcast. I think it's just the Audra Nash podcast. If you haven't listened to it, this is definitely a technical podcast. If you're into robotics, that you need to listen. And so I follow him on Twitter, and he just said that Gronk is doing a much better job. Apparently, he has access to it in Germany. You don't have access to that yet. So he said that Gronk is doing a much better job in going through his code and helping him writing the code than Perplexity AI Pro. That's what he said. So, and you were just mentioning other large language models. So, do you use it for coding? So, do you use it for
Uh, I
having a look
I
at it?
particularly I particularly use it to debug the code when I face errors. Sometimes those errors are like very vast. So to save time, I put the errors into the code, try to see, okay, explain this error to me and tell me what I need to do. But
Mm.
I don't use it to write production level code because it is not always optimized. It is not the best way to do it. And it is so confident that it can change your entire thinking process.
Mm.
It will, whatever you ask it to do, it will say, certainly, okay, I will do this. Yes, you can do this. Yes, this can work like this. Very hardly you will see that the large language model says that, no, this is not possible. No, this is not the right thing to do.
Mm.
Either you need to understand how to prompt, or you need to understand the concept so that you can take your own decisions and not let
Mm.
its decision, influence what you think.
You should use it
So
as a tool versus
yeah,
let it actually do the work and yeah, I
yeah.
got it.
And then there comes a point of, what if that code is, it learns from some other code base, it is trained from some other repository, and if you reuse that code, you don't know how much of the code is being reused. You can also face problems of plagiarism, or anybody can file copyright claims about on that code if you publicize it or use it for commercial applications. There has to be
Mm.
some regulations about these. So
Mm.
this is a very small example, but this actually can be a legal issue if not handled like cautiously. So
Mm.
I don't risk this. I personally use it for understanding how to the solutions, so brainstorming solutions. So this is my problem, I want to find out the most optimum solution, so give me 10 solutions that I can do solve this problem with. Or this is the error, what is the error about, help me understand it. So
Yeah, I think this is definitely something that not only for coding, but for using those tools in general, they should help and assist you and not really taking over the work. Something else that just came up to my mind and I had on my list asking you was the not only which field should I go in is a big topic, but another thing is always, do I have the right background? Right. So people from mechanical with a background in mechanical engineering, or people with a background in computer science, or people with background in yeah, different kind of engineering. And they said, okay, I would like to um, become much better working with robots, and I would like to dive deeper into those topics. So what is your advice to that? I mean, you said that your path had been very strict and very straightforward, but with someone coming from a different background and not maybe having not having all the necessary tools and skills that are necessary to go into robotics, what would be your advice to those people?
I would like to begin this answer by saying that anyone can be a robotics engineer. Anyone can learn this. It is only about the willingness to put in the right efforts. And to put in the right efforts, you need to know what to do first. So what I gather from this is, anybody who has some mathematics background and you understand certain level of physics, you need to have a strong hold of mathematical concepts like linear algebra, calculus, which includes differential calculus as well, and vector algebra. You need to understand probability and statistics, and number theory, numerical theory, and you also need to have some experience with Laplace transformation. I have everything written down here, and I will share my screen later on. But you need to have this experience with mathematics, solving maybe your academic background or something in your past should support all these, because if you don't have that background and you try to learn everything together, then you will spend a lot of time to learn all these concepts, and then your journey will begin from that point. And I think a foundation in mathematics and a foundation in physics is important, because even the code is math driven. All the algorithms, every library is math driven. And if you don't understand the basic mathematical concepts like partial differentiation, the whole Jacobian concept in robotics is based on partial differentiation. So if you don't understand partial differentiation, then probably you will not understand Jacobians, and then you will go back to the mathematics, learn that, and then come back to it. So basic foundation in math and physics is important. Apart from that, no matter which branch of engineering you are from, or even if you are from a non-engineering background, if you get the right guidance, if you know that this is what I want to be and what I want to do, then you can shape your entire journey for that goal. But to fix that, so let's say, okay, this is a very vague statement. I want to fix what I want to do. So if you are from, let's say, a chemical engineering background, and if you want to be a robotics engineer, What should be your path? What should you study? So first go back and take a step back, see what have you already studied. Since it's chemical engineering, you have studied mathematics, you have studied equations, you have an understanding of how things work structurally. So your mind is trained to do that and leverage that knowledge and transfer it to the skills that are required for being a robotics engineer, starting with programming. Even though people around us are saying that it's not important and not required and it's going to be obsolete in the near future, but that future is not right now. And uh, right now the job descriptions specifically mention C++ and Python, sometimes either of them, but most of the times they require both proficiency. And no matter what background you come from, I have realized this, that when you apply for a robotics software role or robotics engineer role, everybody in the company who interviews you expects you to have certain software proficiency. You need to have an understanding of how to write code, how to test code, how to write readable code, how to write good code. What is good code? And if you don't know how to do that, then this is your cue and this is your opportunity to start learning and understanding how to write good code, because that is going to affect your chances of being hired. No matter how much theoretical knowledge you have, no matter how much Python experience you have based on projects or your internship experiences, if you cannot work in a team, if you don't know how, what are, let's say, what are continuous integration, continuous delivery, or deployment pipelines, if you can't work in a team of, let's say, software engineers working towards a robotics goal, then you probably won't be selected for that role. So having that experience is important.
I think the because now we're talking about software engineering, right? And a lot of people are asking, should I go into software engineering or should I go to hardware? I think this is definitely something that is really depending on what is natural to you. Because I experienced this on my own. If you're trying to be good at something that is not within your interests, then it becomes very hard to become good at it, because you do need to spend a lot of time with something to become good at it, right? So if it's against your nature, if it's against your interest, then it will always be much harder for you, because you first need to convince yourself that this is good for you and that you would like to spend time on it, versus the person who loves to spend time with that, and so that experience this not as work, rather than I love to do this, I love to spend time that with that. Mm, you were mentioning the importance of being able to program. I think in general the bashing in, yeah, it doesn't make too much sense to learn some facts, because all the information is at hand and you can Google everything. But I think it is still very underrated, because in the very end you do need to have facts, the factual knowledge, and then you can apply frameworks to it, and then you can apply a way of thinking to it. Because how would you like to think if there's nothing you can rely on, or you can come back to it, right? So there is certain points of knowledge, and then comes the hard part to actually combine them or connect them together to come to something new, right? So saying it doesn't make too much sense to learn hard facts. This is a skill, right? This is a skill too, and it trains your mind to learn things. And as you said, if you're going through university path, and a lot of people are saying, no, you need to spend time on practical projects, which is definitely very, very important and has a very big learning curve. But going to university, going to school, and spending time is not only yeah, you can show to someone that you have dedication, or that you can just work as a working bee. It trains your mind. The way you think is structured like that, and over time, the way you approach to problems will differ from those who didn't have that kind of training, right? So it does make a lot of sense to spend that kind of time and to work on difficult projects, and math, for example, because in the very end you will come out stronger out of it, and your mind will be shapen by that.
Absolutely, I completely agree. N- the textual knowledge that we take is important. It disciplines your mind, it trains your mind that you can pursue this course, understand this concept, and solve an exam, and that is expected out of you. So I think somewhere down the line it is important, it makes you a better learner. And all you need to, if there is one thing that I can learn from the university, is to be how to be a good student, how to be a good learner. I would want to learn that, because nowadays roles are not monotonous. They keep changing every year, every 6 months. You need to keep up with the technology, keep up with the new trends that are happening. uh, just your next day your company can entirely rip off your current software and implement a new software protocol, and then you have to learn and adapt to that situation. So if you don't know how to learn, if you don't have a learning process, and you have not evolved your learning process, then it is going to be difficult for you to uh, do a job. It is not just about passing the exams, it is also about surviving, understanding how I can be a student, how to learn. And you're right that we can search everything on Google, it's all available. And some of the interview processes don't even make sense. They interview for a robotics engineer role, and they want us to sort two arrays of integers. So, and now you must think that how is that relevant to the role? To that, I don't want to justify this type of interview procedure because I don't fully support it, but then they're checking how much of the basics you have covered during your undergraduate, because this is something that you learn during your first or your second year. And you should have that experience, you should have that proficiency, that no matter when or where they ask you this question, you should be in a position to do this. So it shows that how disciplined you are as a student, and that will seep into your professional life. So that will give you a part of your discipline. If you can be a good student, there are high chances that you will be a good employee or a good person working for an organization. So that's my take on it.
But this is totally this is a different stand on the sorry. So when you see on social media, you see a lot of people. Yeah, you don't need to be a good student. You don't need to be a good employee. You need to be a good entrepreneur, and there are different skill sets that are necessary for this, right? And I do agree partially because there is a different skill set and there is a different characteristic behind that to become an entrepreneur, right? But I think the discipline is necessary for everything you would like to achieve. So if you are only thinking about, okay, you would like to, if you're a good student, then you become a good employee. Or you can think about it. So if you can discipline yourself to learn for an exam, then you can discipline yourself not only for an employer, but you can discipline yourself towards a goal that you have. And that goal, as you said, for example, can be becoming a good programmer or becoming very good with a certain domain that you would like to become good at. Because only having goals without having the tools and the skill set and having discipline is a skill, and having so not having the guts to sit down for a certain amount of time, for a longer period of time, to work at certain task, you cannot become good at it. So, uh, not looking down on school or university and these kind of skills and then you're just becoming a worker bee. This is actually a skill set that frees yourself. It gives you the opportunity to reach and achieve everything you want. And especially if you would like to make a career change, if you would like to apply for a job that is with a skill set that you don't have yet, I think this is very valuable.
I completely agree. Being a good student is will not guarantee that you'll be a good employee, but it will guarantee your discipline. It will guarantee somebody who gets good marks at least has the discipline to study for that exam and vomit whatever they have studied. That's also a skill that's hard to find, and that's why there is only one topper of the organization or the institute. This is a hard to achieve skill, and it requires practice, it requires dedication, discipline, willingness, and not everybody can do it. So the more you do it, the more you train your mind. And when challenges come during your workplace where you don't have mentors to go to and talk discuss these problems, you don't have a group of friends, you can't do peer learning when you're at a job, that time these skills that you have acquired, how to learn, how to quickly adapt to different situations dynamically, that will give you an edge over everybody else. How to handle stress, how to meet deadlines, it's important.
It's good that you just said it. You were mentioning mentors again, and I think I would like to come back to something that we talked earlier, and you would like to dive into. If when people asking for guidance, and they're asking for, can you be my mentor? And yeah, a few things that you said was trying to find the right mentor, trying to find the right person that pushes you in the right direction, someone who saves you time, someone who saves you for doing some mistakes that are not necessarily need to be done, and but also networking, right? So maybe we can spend a little bit of time on that. So you said networking helped you very much, and you said having a mentor helped you. How can you find one? How can you connect? And maybe spending a little bit time, because I think you would like to share some personas that people
Yeah.
can connect with.
Yes, definitely. So I would like to begin this that everybody should have one mentor that they can trust, that they think that they can guide them well. And the way you find them is, see, charity begins at home. You need to know your organization, your institute, your university. Try to look at your department, the teachers you have, respect them, talk to them, build a conversation, a rapport, and try to understand what their expertise is. Try to do some reading about their work. Try to do some research about what they do. Reach out to them, share your goals, share your determination and discipline, and then ask them for advice. Ask them that are they willing to guide you for a certain project, or what do they think should be the next move for you, and they will be the best resource person to do it. And most of the times these teachers and these professors have their degrees from good reputed universities abroad or in your home country, and they can even connect you with different universities, different people that are in contact with them. But if you don't initiate that first conversation, you will miss out on all these opportunities that are just behind an initial conversation. And I'll share one anecdote with this, supporting this. The way I did this was, when we were under the lockdown situation, our university was partially open during 2021, and they called us back. Some people came back to the university, and there were like 10 to 15 students who came back to the university to attend classes in person. Nobody wanted to attend in person, they all wanted to enjoy, and which is fair enough. Everybody ha- has an equal say on what they want to do. I wanted to go and learn from by sitting in the classroom. I used to be the only student who went to the classroom, sat in front of the teacher. The teacher had the laptop on, they were addressing the crowd virtually. I was in person, and there was a 10-minute gap between each lectures. And the only reason I went to the university was to spend that 10 minutes talking about anything but academics related to my career, my projects, my domain. And those 10 minutes throughout the entire semester accumulated to around 300 minutes of one on one time that nobody can steal away from me. The insights that I got during that time are invaluable because nobody else got it, even though many people had that opportunity, but they just didn't take it. And all it required was to grab my laptop and go to the university, sit on the bench, and learn. Do the same thing that others are doing from their hostel rooms or their home bedrooms. So that is a part of my decision that created a very huge impact. And that's how I started to get opportunities from different organizations, from different institutes. I started to meet different people. It opened up doors for me because I took that initial step to network. And this is at your university. Think about the things you can do when you approach people on LinkedIn, when you email random people on LinkedIn, email professors from other universities, students who are maybe pursuing the same degree but in a foreign institute. Talk to them, try to have a conversation about what they are doing, how they are doing things, what are the differences in the approaches, what are the educational differences. You will get a lot of exposure, and in that way you'll understand on what is better, what is right, and what's happening around the world. Because usually what I've noticed is these people are in their own bubble. They don't know what's happening even in their own country, in different institutes, what are different competitions that are taking place, and competitions, hackathons, or robotics competitions, uh, and robotics conferences, ICRA, IROS, ROSCON. All these conferences are extremely important if you are an aspiring roboticist. And you have to know about all these things. And the only way you will know, either you look up the internet or you have people talking about them in front of you so that you get that exposure passively. So this is all important. And just a quick point about networking. You need to have a team, you need to have a group wherein you are not the smartest one. If you are the smartest in your group, you're in the wrong group. Change it, adapt to a better situation wherein you don't know 10 things that others know, and keep finding that group wherever you go, because that will only help you grow. Otherwise, if you are the smartest one, then you are pulling everybody up. Now, who is going to pull you? So you need to have a group, and which pulls you, makes you a better person, makes you a better learner, exposes you to different technologies. I think you had a point. Do you want to share something?
Yeah, I'm thinking about the drive that you have and the guts that you have to actually participate in this kind of things, to actually drive yourself forwards and put yourself in this kind of position. I mean, because you're still very young, and I do remember that when I was that kind of young, I had a lot of false confidence. So I was cocky, but not based on anything. And over time, you gain experience, and over time, you gain skills, and then you reach a certain stage where you can actually point the finger and, okay, this is proof of the things I'm claiming to be, I am, right? But coming back to how can you, what kind of advice can you give to people that have not that kind of drive, that don't have that kind of outgoing um, personality, and don't have, or yeah, just being shy and not having the voice, not being used to raise the voice or ask questions or be the one that is yeah, having the guts to be stupid too, right? Being coming into a group and knowing that you're not the smartest ones. So this is the reason why a lot of people are staying with the other ones, because then you can feel smarter versus you feel dumb. But as you said, if you can put yourself in a position where you are the dumbest person, you can actually gain so much more from. So what kind of advice would you give to people that would like to do all the things you just mentioned, but haven't done them yet and have a lot of problem to overcome that barrier?
That's a very good question, and I did address it when we were having internal meetings with my team. So the advice is, you need to understand your why. The earlier you understand why you're doing certain things, and understand the value that went behind your position in that place at that point of time. Think, no matter how rich you are, no matter how much money you have, but think about the sacrifices that your parents had to make, that your family members had to make, that you are currently making to be in that position. If you understand your value, the value of what you have at this point, if you understand your why, if you have the confidence to fail in public, to do some stupid thing in public, like a responsible stupid thing in public, then you become impenetrable. Nobody can, challenge you or cross you or say anything to break you. I think everybody needs to take that step, to be that person, to put yourself out of your comfort zone, do something that is out of your comfort zone. And if there is one question that I like to say this to the people I talk to, at the end of 4 years or 3 years of your undergraduate degree, what are the top 10 things or top 10 achievements that you have? And if you don't have that right now, start doing things so that if I ask you the same question 2 years after, down the line, you will have 10 things to talk about. If you don't have that, then think about the time that you have wasted, and you have not made most of what you already had. Think about the people who don't get what you are having, and you are in a much better position. You know about your worth, you know about your luxuries, know about your privileges. And when you have that self realization, when you know your self worth, that's when you try to put yourself out there, because there will always be a hunger to know more,
Hmm.
to improve your standard, to grow, to understand what others are doing. And that's how you kill that barrier of, okay, I am shy. Start small. Start by talking to one person, start by sharing your journey, academic journey or your project's journey, and discuss. And from one, try talking to two people, then talk to your mentor, your teacher, your professor, after hours, after work, after university, after lecture. Just talk to people and have a conversation. They are not going to drag you down or demotivate you. That's my guarantee, because that nobody does that. No mentor is going to demotivate you the minute you start sharing anything. So you just have to take the first step, and take the first step every single day. Do something that's new every single day. And as you rightly said, after a period of time, it will start compounding. You'll start to see the benefits of doing that. Spending 5 minutes with that person or with that teacher will help you to understand things much better after your semester or after your year. So take that initial step. It only requires a drop to create an ocean. Every ocean is created of drops. So you need to keep doing that. Be in that 1% improvement zone. You have to improve yourself 1%. Try to get as much knowledge as you can, because that's something that nobody can steal from you. So do that.
Yeah, again, I think this is you are very far in your journey, mentally at least. I think for all the ones starting out, to climb the mountain, it's way too hard, right? And as you said, you should start with smaller steps, smaller achievements, and then because when you go into the gym, it's the same, right? If you're gonna take a big if you take a big dumbbell, you cannot do it. You need to start with a smaller one and work your way up. And I think this is definitely, and if you do this continuously, it gets easier and easier. So I think this is definitely an approach that is applicable to almost all things you would like to achieve. Um, I do know that you would like to share some information. I would like to give you now the opportunity to
Thank
shortly
you.
give an overview, not diving too deep into it, and especially here I'm thinking about my friend that is listening to this podcast. Not showing too many visuals, but we show some at the moment. But you will talk about them. So let's
Yes.
spend some time about with them, but in a more broader way.
Yes, definitely. And good thing that you mentioned about going to the gym. I go to the gym to build that discipline, and I share
Mm,
that story with everyone. So
mm.
that's a good way to train your mind. That's just a small thing that I wanted to address. Uh,
So
in
what are
this
we
slide,
looking at?
so right now I've shared my screen, and I've prepared around 7 slides with profiles of the people, my friends who are a part of my team. And we just work together and share together, share the knowledge about robotics and different domains of engineering. And I reached out to them, and I said that, hey, I'm doing this episode. What advice would you like to give the viewers? Or I would like to bring you all, since I cannot invite you all, let me just invite you through your words, through your experiences. And that's how
Maybe
I
in the future.
invited them.
Maybe in the
Definitely,
future
definitely.
we have a bigger
Yes.
round. But I think what's important here is so everyone who is listening, so you can come back to the YouTube video if you want to, and what you can actually see is an overview about different skill sets, about different topics that are necessary for going into robotics. So if you are really interested in how can I build my career, how can I shift my career going into robotics, then have a look at the YouTube video. And there's a lot of things that my dear friend is sharing at the moment. For those who cannot watch, I think he will talk a little bit about what you can read here.
Yes, definitely. I just want to uh, say out a few jargons that in
Hmm.
terms of mathematics, the concepts that you need to know are linear algebra, vector algebra, calculus, Laplace transformation, transfer functions, matrices, forward kinematics, Jacobians, inverse kinematics, and dynamics of robotic systems. If you talk from a control perspective, you need to understand the famous PID control, stability in control systems, what is discrete controllers, state space modeling, nonlinear control, robust control, fuzzy logic control, etc. If you are thinking from a perception point of view, then visual or proprioceptive or exteroceptive sensing is important. Try to Google these words, and you'll get a lot of information. Talking about sensor fusion, you can learn about Kalman filtering, particle filtering. If you are into SLAM, post graph optimization, graph based SLAM, mono SLAM, stereo SLAM, orb SLAM, visual SLAM, all these are different types of SLAM that you can explore. And there are different domains that can be integrated with robotics. They are machine vision, they are machine learning, they are deep learning, reinforcement learning, federated learning. I have explored everything apart from federated learning. Reinforcement learning was a part of my dissertation, my master dissertation. If you are into like core robotics, then there's wheel robotics, bipedal robotics, quadrupeds, hexapods, octopods. So try to read more, try to understand how these work, how the kinematics work, how the joints are actuated, what kind of math goes behind the actuation. Then there are drones, underwater robots, soft robots, medical robots, nano robots, humanoids, cobots, exoskeletons, telepresence robots. There's so much different domains that you can explore. Try to explore them on YouTube, go to GitHub, look for repositories, read blogs. There are endless opportunities online. And remember that you miss every shot you don't take. This is one advice. I don't know who is it from, but I follow it every single day. I don't, just try. If you don't ask, the answer is always no. So try to create a presence, develop your website, document your progress, share it with people, and then in the process you'll learn a lot. All this information is also on my bio link. It's for bio.link/Akshet Patel. You can go. And now I'll explain the importance of networking, because I shared this with my team, and they suggested a lot of things. I'll quickly skim through it. The first person was Adi Shesha Reddy, and you can look him up on LinkedIn. And he advised people on going through the articulated robotics YouTube channel. And ROS training fall 2020 is a playlist by RoboJackets training. It's also a robot operating system playlist. And you can also explore the course by Ducky Town. It's called Self-Driving Cars by Ducky Town. It's a MOOC, so it's free, and you'll get to understand the different aspects of robotics, from implementation, from understanding the concepts to the implementation. My friend Jatin Veera, who is a robotics engineer working at a robotics company in India, he has a 2.5-hour recording of getting started with robotics in his first featured post on LinkedIn. So just go to his profile, scroll down to the featured section. The first post has that link. The next is by Kaushik. He mentioned that failure is also an important part of this process. Be ready to fail. If you fail, take it as a learning step, and don't be afraid to fail. And try to build small projects. Start small, but then convert those small, compile them into a major project. Then Umesh Mane, he said, he's also a robotics engineer. He works at a company, and he said that you need to explore the basic concepts first, and then work your way up to the complex aspects. He was talking about robot operating system. Start with publisher, subscriber, topics, nodes, service, clients, action servers, and then go to simulation environments like Gazebo, Arviz, or different concepts like Odom or TF. Then you Sahil Raut, he's a student at in the UK. He's studying his bachelor's course in the UK, and he mentioned the importance of debugging, how debugging is important. And this is what I have observed during interviews as well. Robotics interviewers want to know how to debug your code, how to know that your code is testable, how to simulate the tests, how to write test scripts, how to understand where your code will break, what are the edge cases, or just the importance of troubleshooting. That's a very important skill, and it will only come with practice. You cannot learn it by theoretical knowledge. It only comes with practice. Karthik Motiki, who works as a robotics engineer, he advised people to find your niche by exploring. You have to start with different AMR platforms, and then try to explore as much as you can, and work your way up to the niche that you're currently interested in, that you would like to explore more. So exploration will lead to narrowing down your domain. Then my friend Darsh Jopanputra mentions the importance of mathematics. He has reiterated the mathematical concepts as well as the robotics concepts like robotics, kinematics, dynamics, control systems, and machine learning. And also he has focused on CAD tools, which is computer aided designing tools like Fusion 360, SolidWorks, or CATIA. You can he is a Linux developer. He programs on Linux, and he has quite some experience with Linux. So he is emphasizing the importance of Linux as an operating system for roboticists. Even I have a dedicated laptop running Ubuntu for my ROS and ROS2 applications. So every roboticist, if you want to be a roboticist, I think you should have some proficiency with Linux commands, just Linux development. And finally, my friend Joel, who who is also a robotics engineer, who is an aspiring robotics engineer. He emphasized the focusing on Linux using Raspberry Pi, get some hands-on experience so that this can be converted to projects and the projects can be converted into major projects. And he emphasized the focus on ROS 2. ROS 2 Humble is getting pretty mature in terms of packages and support from companies. And he would recommend that you learn ROS 2 from now on because ROS is reaching its end of life and companies are switching to ROS 2. So there are multiple resources that I can share about ROS and ROS 2, different books that I can share, different videos. You just have to drop me a message and I will try to provide as many links as possible. Thank you for this opportunity, for making me able to share my friends' work with you. And I hope this helps the viewers. So thank you.
I think the thanks, thank you is coming from me and from the audience because what you were trying to do, and I think you accomplished this, is people were asking and reaching out to me after our last episode. Can you help us guiding us how to get into robotics, how to get better, how to switch career paths? And here you were trying to be very dense with the information to put it everything in as short as time amount of time as possible. So you not only gave your own advice, but you gave the advice from friends and people that you're working together with. What is their advice? Because there are people that are already working in robotics, in the robotic fields, in different domains. And what is their advice? So I think everyone takes pretty good or is doing pretty good if they are taking that advice. And because there's no need for doing the same mistakes over and over again. This is the reason why it is important to talk to people that are more experienced than you. This is the reason why it's important to spend time with people that are further in their journey than yourself. So you don't have to do the same mistakes. I mean, you do need to do mistakes because you learn much more from your mistakes than from your wins. But I think this is a good way to end this episode today. I'm very thankful that you took the time and that you, due to the high demand, were so kind to spend your time again with us. I am thankful that you provided so many resources, and I think you said that afterwards you will share some more with me. So I will post this on LinkedIn, on Twitter, and on YouTube, and I think I will pin them. And your friends as well, so people can reach out to them. And yeah, I'm very happy that you took the time.
Thank you. Thank you for this opportunity. And it was a pleasure to share all this information. I know it's very overwhelming. So just take notes, try to note down the points and do your research. Take your time, reach out to people and talk to people how to understand. And I'm sure people will help you. And I'm not an expert, and I'm sure nobody is an expert in the field of robotics. But the more you talk to people, the more you reach to that expertise level. So
Mm.
this is your journey. You have the information now, nothing is stopping you. Wish everyone the best who is watching this, and thank you for this opportunity once again. Have a good evening.
You too. Take care,
Thank you.
and I think this will definitely not be the last episode I have you on.
No worries. Thank you.
Have a good evening.
You too. Bye.